Hi class, this video is going to be on adding and subtracting rational expressions. I guess actually specifically we're going to be doing subtraction here. So the very first thing you want to do with these problems is factor them if you can before we find common denominators, because in its current state that's going to be kind of hard. So notice right here that this is the same thing as x squared minus 6 squared, which means it's a difference of squares. And for this one, I can probably factor it into, let's see here, x plus 6 times x plus 3, right? 6 times 3 is 18, and 6 plus 3 is the 9. Okay, so now let's go ahead and take all of that facts and rewrite this problem. So we're going to get x plus 2. Well, since x squared minus 36 is x squared minus 6 squared, that gives us x plus 6 times x minus 6, because it's a difference of squares, minus x over, now this one needs to become x plus 6 times, what did I say? X plus 3. Okay. Now, in order to do subtraction, I need to have a common denominator. And notice I just erased my equal sign because I broke my rule of saying make sure you have lots of room. So I'm going to stick my equal sign way over here. And in order to get a common denominator, the one way I like to think about it is I look at my left fraction and I see that it has an x plus 6 and an x minus 6. And then I come over here and look at my second fraction and its denominator and ask myself, what is in this denominator that is not in this one? And the answer to that is the x plus 3. So since that is missing, I'm going to go ahead and multiply my first fraction by x plus 3 over x plus 3. And then just to play it safe, I'm going to make sure I put all of my parentheses so that my next step I don't make any errors. Now I do the exact same thing, but on my second fraction. So the denominator of my second one has an x plus 6 and an x plus 3. And now I ask myself, what does my first fraction have in its denominator that the second fraction does not? The answer to that one is x minus 6. So I'm going to go ahead and multiply my second fraction by x minus 6 over x minus 6. And again, I'm going to add parentheses. Notice that here with the x, I didn't have to technically put the parentheses. However, it's a really good idea to, because if that was a bigger expression than just an x, and you did not put your parentheses, you'd run into issues. Okay, so now we're going to rewrite this with all this multiplication happening. So this is going to give me x plus 3 times x plus 2 over x plus 3 times x plus 6 times x minus 6 minus x times x minus 6 over x plus 6, x plus 3, times x minus 6. So now my two fractions have the exact same denominator. I mean, even though it's written in a different order, like the x plus 6 is here, but then here on that one, it doesn't matter because multiplication can be done in any order. So now that they have the same denominators, I can go ahead and add the numerators. So when I do that, I'm going to get x plus 3, x plus 2, minus, and again, this parentheses may be unnecessary for this problem. However, it doesn't hurt to put them because it's better to over-parenthesize than to under-parenthesize and get the problem wrong. Now when I add fractions or subtract fractions, in this case, with the same denominator, that means when I do the subtraction in the numerator, the denominator just gets the the denominator that each fraction has in common. So I'm left with this. Now, I'm not done. The numerator is actually still kind of, involved. So my next step is to go ahead and simplify my numerator. And the first step in that is going to be able to look at this and to FOIL it. And over here, I can also distribute that x squared, or the x, into both the x and the -6. So for this problem, it looks like I'm going to need to bring in some room. So let's delete all of this up here. In fact, let's just go ahead and delete both rows. Okay. Get back my pen. So FOILing out the x plus 3 times the x plus 2, this guy, is going to give me x squared plus 2x plus 3x plus 6. And now I'm going to look at distributing this x, and that's going to give me minus, and again, this is why the parentheses are important, x squared minus 6x. And here at this step, those parentheses are necessary, otherwise it changes my answer. So I have those parentheses, and I'm done with my numerator, and my denominator doesn't change. Remember how I told you in class to never ever FOIL out your denominators, because it's kind of going in reverse. You know, the goal is always to simplify, and factored is simplified. So if it's already factored, then you're good to go in the denominator anyway. So now in the numerator, I can combine like terms. So I'm going to get x squared 2x plus 3x is equal to 5x plus 6. And now I'm going to go ahead and distribute that negative right here. This one's going to go to both terms, giving me minus x squared plus 6x over x plus 3 times x plus 6 times x minus 6. We're getting close. I need to erase some more room again. So let's go ahead and erase all of this. Again, I'm going to still be combining like terms because the numerator still has some stuff that can be combined. So let's see here. We have an x squared. Oh, look at that. We have an x squared minus x squared, which means they cancel. And then I have 6x plus 5x. So that's going to give me 11x. So it's going to equal 11x. And then I still have the 6 right here. So plus 6 over x plus 3 times x plus 6 times x minus 6. And now I would ask myself if I can simplify anything. And in this case, I can't. There's nothing I can factor out of the numerator. The denominator is already factored. And neither the numerator or denominator share any factors that can be canceled. So I'm done. This problem is now finished.
Made with Doodlecast Pro.